All right, 2.2 is covering the properties of radicals. And some of this is going to be familiar to you, and some of it will be brand new. Okay, I want you to make sure, I'll try to break it up so you have some time to digest things and then work on portions of the problem set. Okay, but if you have questions on anything, please ask, and then I'll also emphasize to you when I'm going over stuff that's new and that stuff that causes the most problems on the final. Because stuff from this section is part of what is missed the most often on the final. All right, we'll start with just the basic stuff that you should have been exposed to already. Okay, a radical has the following form. The nth root of a to the nth power. Okay. Or actually, let's leave out the power for right now. I'll add that later. The radical just has the form nth root of a. And when you're looking at this n value is called an index. And the answer to this, the nth root of a, is actually equal to the number that can be multiplied by itself. N times to get the product A. So that's what the nth root or any radical, the index, means. And the most familiar index that you guys have worked with before is one that's not even written. If there's no index written, it's considered what number? Not 1. 2. It's one number can be multiplied by itself 2 times to get the number in the radical. So when you're looking at this, what number can be multiplied by itself? And when I say multiplied 2 times, it means that number times itself to give you 4. The square root of 4 is 2. Because 2 times 2, this number multiplied by itself twice, is equal to 4. Okay, so the square root of 4 equals 2. What about the square root of 6? Does that equal a whole number? No. It does have a value, but it's an irrational number. Okay, so you need to be able to realize which radicals can be reduced completely and which radicals, again, give you some real number value, but it's not in a rational form. Okay, anytime you have a perfect square inside of a square root, so right here, if we're talking about square roots, again, the index of a square root is equal to 2, even though it's unwritten. Okay. When we're talking about square roots, anytime you take a square root of a perfect square or a perfect power, it reduces out to and can be simplified to a whole number. 4 is a perfect power. 4 is 2 squared. Therefore, the square root of 2 squared is equal to 2. 6 is not a perfect power. What's the next perfect power past 2? Or I'm sorry, past 4? 9, right? 9 is equal to 3 squared. So the square root of 9 reduces down to a 3. What about before 2? What perfect power exists? Square root of 1 squared is 1. Again, if you take the square root of 1, that is a perfect power. Okay, so you need to be able to recognize these. Did I talk about this in class yesterday with you guys, or was it a different class? How you need to recognize perfect powers. Okay, so if I gave you something like this, the square root of 25, well, how can you think of 25? It is 5 squared. And one of the ways to simplify all radicals is if you take the nth root of a to the nth power. So if your index and your power are the exact same number, your number is going to simplify out to just the base. Okay, so Again, if you think of 4 as being 2 squared, the square root, again, an unwritten 2 is the index. If the index and power are the same, all you're going to do is remove the base, and that's your simplified form. And now, we'll talk about this either a little bit later today or next class. You also, though, need to consider that it might be the absolute value of A, and we'll go through that in detail. For right now, we'll emphasize this part of it. Okay, so if I gave you something that was the square root of 49, what is that going to simplify to? 7, because you're looking at 49 as a perfect square. Therefore, index and power cancel, leaving just the base of 7. Okay, I want you to look on page 13 at sample problem 7 and see if you can answer those questions. You should be able to answer them extremely fast, pretty much instantaneously, and we'll talk about it here in just a second. And so what is the square root of 81? 9. Is it 9 and negative 9? Is that plus or minus 9 or just 9? And don't let me confuse you, but this is one of the places where students tend to get confused. Okay? If you're evaluating a radical, so something like this, root 81, if there's no sign written in front of that, what does that sign assume to be? Positive. So when you evaluate the square root of 81, it's basically asking you to evaluate the positive root of 81, which is positive 9. The only time that you guys are going to use the plus or minus is if you're solving an equation. Okay? So if you had the equation x squared is equal to 81, and in the process of solving this equation, you did what's called extract the square root. So you take the square root of both sides, you get x is equal to. So now this process right here, in the scope of solving an equation, you do have to account for the positive and negative root. Okay? So be careful on that. We're not solving equations yet. That comes in one of the later chapters. So you don't have to worry about the positive and negative roots. You're only looking at whatever happens to be labeled. Okay, what about B on sample problem 7? Again, index and power are the same, so you just pull out that base, the base of 4.7. And then finally, the square root of 1 over 4. Okay, and that reduces to 1/2. And 4 is a perfect square. It's 2 times 2, or 2 squared, so that power, or that radical and power cancel, leaving just the base of 2 in the denominator.